Well, a little nervous. Let's see how this goes. Oh, not good. We let out the magic smoke. Fuck. Ah, fuck. So this video is a journey. No, it's a quest to not just fix a broken amplifier, but rather a situation where I was forced to learn, figure out how to use my testing tools like an oscilloscope, learn how each section of a Class AB amplifier works. What you just saw was after what I thought when I had fixed it. So sit back, follow me on the journey and bringing this amp back to life with help from my good friends David and Dan. So this journey began with finding a very mint amplifier on eBay with a return policy, and as you can see in a previous video, we tested this thing. The seller graciously refunded my money and allowed me to keep the amp, so it was on. Got a couple of these different versions of these, and they are really nice amps, and so I have a big 2-channel, so I was looking for a 4-channel amp. And so I'm going to show you why I think it was a good deal and let you know kind of how I sort of bargained to get this thing for an even better deal. On the bench, and let's power up, see what she does. All right, we got all green lights, no red lights, which is a good sign. We don't have any sound. And I already checked these channels, and I now checking these channels, and for some reason it's not going into protect, it's not doing anything bad, but there's no output. So let's crack this thing open and see if we can find a problem. So in my first attempt to repair this thing, I found that there was a couple of FETs that were burnt out in the power supply section. So that was a fairly easy diagnostic, and I just replaced those. All right, so we got the Sony. I'm getting ready to put it back together. I want to point something out. So this is what they call an insulated case. Okay, so you'll usually see like an F or something after the part number. And what I found out was these tend to not be all that robust, but what they do allow you to do is just, these are the rectifiers, but just screw them right to the heat sink without having to use clamps. And I don't know why they went this route. I'm replacing these with ones that aren't insulated backs. So this is conductive, and it will short out if you just screw it to the heat sink. So I was able to get the TO220, these are sill pads, and then where the screws go, there's actually these insulators that keep everything from shorting out and making electrical contact with the heatsink. So anyways, you got to put the paste and the sill pads and the insulated screws and get them all soldered in. We're going to do that. See if this thing powers up. So I showed you the results of that and the smoke rings that came out of this thing at the beginning of the video. So let's see what happened. Well, as you can see, this thing cooked. I haven't seen one smoke like this in a long time. So I don't know why this would be, but when I showed you previously that I put the sill pads in here and the isolators between the screw and the FET, it really should keep this from being grounded, because this heatsink is grounded and the screw is connected to the heatsink, but the screw should be isolated from the body of the transistor. The sill pad should be keeping the transistor from making contact with the heatsink. But when you check continuity, all these things are grounded. And I don't know why, but that's why they freaking blew up. So I need to check and see what the hell is going on and why this happened. This is nuts. As you can see, it really damaged the traces on the pad. It actually lifted it. All right, so I've been working on this thing. I replaced all the input FETs. I did realize that they were not grounding out by the way I was mounting them. I'm pretty sure that there was a couple of things that may have contributed to it failing again, or not working, I should say. I did have an output transistor that was smoked. And so what I'm doing right now is I'm isolating the power supply from the amp section. And so I took the PNP, NPN, these are push-pull transistors, and these are what drive the power supply. This is an important step that I've learned in amplifier repair. You can also remove the rectifier diodes, and that'll isolate the power supply from the output section of the amplifier. And once you have a good working power supply, then you can move forward to the amp section. So it just limits, how many things you're working on at one time. So they're out, and so nothing's going to be going to the output of the amplifier. So if there was no problem with this, I did check to see if there was any shorting across the ground and the battery. If you have an amplifier that might be a little suspect, always using your ohm meter and testing between power and ground to check for a dead short is always a good thing to do. Lugs, and it seems good. So it doesn't seem like there's anything wrong in here. So we're gonna power this thing up on 1.5 amps on our limited power supply here. And so that really shouldn't smoke anything. So let's give it a shot, see what we got. Okay, it's on. So we can check underneath and see if we got lights. We've got green lights underneath, which is a good sign. Nothing's smoking, nothing's unhappy. All right, so I put the power supply back together. I put the driver transistors back in. I do have one channel with no output transistors on it. And I've gone one by one and moving the tone generator from different channels. And I'm getting, with the levels set the same on the gain, I'm getting the same output. So I think there's a chance this thing might work. I mean, it still might have a problem as I'm only running it on just under 12 volts and only 1 amp. So, but this stuff's not fluctuating. It usually does if there's a problem. All right, so hopefully we're working on this Sony for the last time. So I've got the transistors that go here, and these transistors have an insulator because the back of these are conductive. Get these in there. Last time I did power this thing up and it worked on the other 3 channels, so I'm thinking by putting these in there, hopefully we can have 4 channels that work, so wish me luck. All right, so we've replaced the transistors here, and we've got it on the low amperage. Got a little over, I'm gonna go about 1.5 amps. And I'm gonna power this thing up and see what it does, see if it goes into protect or what it's gonna do. Up in smoke, who knows? I don't know. That doesn't look good. We got something's making some funny sounds. And we've got the lights are pulsing or something's going funky. So we need to check this thing out a little deeper. All right, I'm doing a little signal tracing on the channel that seems to be having the problem. So the transistors are out of it. So I'm over here and I'm on this capacitor right here, okay? And then it goes out of the capacitor into these resistors, and into the resistor, we got a clean signal. Out of the resistor, it looks like it's kind of slightly not looking good. in the middle of the wave. So then when we go to the next one down, it looks even worse. And then when we go out of that resistor, that's what we get, okay? And so when I check the output signal, there's the good channel, there's the bad channel. And every once in a while, something clicks over here. I'm wondering if that's maybe the protection. I don't know. So anyways, I'm learning how to use the oscilloscope. With the good help of my friend Dan, you know, I traced the signals, which were really hard to see on these traces on this board. They really weren't silk screened into the amplifier at all. And it allowed me to learn how the signal goes through the staging and the capacitors and the biasing and all that stuff. And I'm going to show you really quickly what the actual problem was. All right, so this video's been made over literally a month of just different times and doing different things and trying back and forth. So I traced through the audio signal on this bad channel, trying to basically determine what the culprit was. And what I found, obviously, was coming out of this here was good, out of this capacitor, but when I went out of this resistor into this resistor, it was a shitty signal. And I had the transistors out. And I'm not sure if not having any feedback was causing some issues or whatever. But so now when we go to the output of the what was the bad channel, it looks like that, which looks good. Here's the good channel, right? We can actually go to the other side. So we've got 4 working channels, but the difference was I used transistors out of the ugly Sony that I did the amp rescue video on. I actually just ripped a couple of the output transistors. They're exactly the same as this one. And I put them in there, and I'm not sure if that was this problem on the output section was based on having bad transistors. So what I may do is take the transistors that I had in here before, put them in the ugly amp and power it up and see what it does. But for now, we've got we've got channels that all seem to work. So I'm going to maybe run some audio through this thing, some signals onto some speakers, and see what we can do. All right, well, it seems to work. So I got to credit my good friend Dan for figuring this one out. This was a last-ditch effort of, hey, we don't know what the hell's wrong with this thing. He said, you know what, give that bias adjuster a couple of turns, spray some deoxidant in it, clean it out. Maybe it's got some corrosion in there. And it turns out that was the problem. I ended up putting the original transistors that were new transistors in it back in it, and it worked just fine. So we got the Sony on the actual bench. It's all put back together, and man, this thing is beautiful. So, you know, last time we tried this, it didn't really go so well. So, without further ado, let's power this thing up. I do have a small fuse in there. Lights are on. That's a good sign. We got music. We got subs. Oh, man. All right, so we wanted to give this thing a proper sound test. All right, let's find out and see what this thing does. It's rated 75 times 4. We've got all the channels are loaded down. 4 ohms. See what it'll do. Looks like we got 74 watts. All right, let's try this dynamic 4 ohms. Looks like we got 86 watts. All right, now we got this thing set at 2 ohm stereo, all 4 channels driven. Looks like we got 109 watts. Not bad. All right, let's see what this thing does dynamically. Wow, 162 watts. That's impressive. All right, so we got this thing wired up, bridged, 4 ohms, mono. All the channels are driven. See what it'll do. This is going to be 40 hertz because you'd be running a subwoofer at this. Oh, shit. Well, that wasn't good. Oh, I see smoke. Shit. Oh, fudge. Oh, please, no. Oh, my God. That was the last test. Oh, I could smell it. I don't know if you see the smoke, but it's coming out. Oh, well, in case you wanted to know, it made 216 before it popped. Son of a bitch. I just flipped this thing over and it's still got smoke coming out of there. I don't know if you can see it, but it's literally still smoking out the bottom. Let's open this thing up. Oh, there you go. Oh, shit. All right, so I'm trying to check the output transistors on this thing. And they seem to be, the output transistors seem to be all right. When I go to the base to emitter on this channel that keeps blowing out, they seem to be fine. So when I go to one of the other channels, we get the same reading and there's no dead short on them. So then you go, well, shit, what failed on this thing? Let's take a look. Let's look. It's obvious. You don't need any testing equipment to see this. That thing is done. I mean, we've done blown it up. I've never blown one up that bad before. So if you see there's a pattern, you know, I marked this thing, you know, this was the channel that kept dying. I marked them because there's PNP and NPN. So anyways, we've got good, bad, bad. Well, these ones keep blowing. And I don't know, it's just because of the way the power supply, you know, the power goes through it. I think possibly 2 transistors run the positive rail voltage and 2 run the negative voltage windings on the transducer. Or what? But we got something killed, something burned. I don't know. I think we might have blown up the, yeah, we did. I think the transformer, I think it's blown up. Look at that. One of the windings. They weren't doing this before. So I think that was the fatal blow on this thing. Well, in full disclosure, I want you to know that I filmed all the repairs, all the things, everything. And I was putting the video together and I realized that I didn't really have a sound test of this thing and, you know, nothing that I could use on YouTube. And so I said, well, I plan on using this thing, so, you know, why not dyno this thing? So in full disclosure, this was supposed to be a happy ending. I mean, despite the ups and downs and I think this thing's completely destroyed. I think at this point, the thing is completely destroyed. You know, as far as the transformer just being probably smoked, you know, I don't know. Maybe I have other things that I'd probably want to fix before I want to fix this one again. Because obviously there's something in here causing the problem. If any of you have one of these amps, whether it's the purple version, here's the piece of the trend of the FET that blew up in the power supply. If any of you have one of these, that's maybe a purple one or a red one, whether it's beat up or not, let me know. I mean, this is a beautiful case. It'd be nice just to put it in there. It sucks because I really want two of these because I want to run an active system and I need 8 channels plus the subwoofer to do it. And so these things are great. They sound good. They're quite powerful. It is an Xplod, so you need to keep that in mind. So if you have one, let me know. We'll work something out. You know, I was hoping this was going to be kind of a good ending. I'm really bummed. I'm trying to hold it back, but it's kind of sucks. So anyways, I do appreciate you guys watching, and I hope you guys learned some stuff. I try to put some tips and some tricks in there, some things that I've learned along the way, and some of these nitpicky things are tough to figure out and learn, and I'm learning that the preamp is pretty complicated, and figuring out what it does in conjunction with switches and op amps and all those kind of things. And so I'm working on it. I'm getting better. I have a bunch of amps tore apart right now, so I don't know if I'm going to get to this thing anytime soon. So anyways, we'll catch you next time. Hey, don't forget to like and subscribe.